So I'm going to talk about multidimensional that could have everyone's undivided attention. You guys have triple dimensions, but that's not so right. It's the rectangular arrangement of something, numbers, values. So, let's say I have numbers in here, and I don't want to fill them all up. And so these things happen all the time, right? If you want to do a Sudoku puzzle, then you would make an array like that. And the way you write them up is a little odd, I guess. In this case, there would be an array of integers, but you have these two slots indicating that you have both rows and columns. And then to construct one, you would say new int. How many is this here? How many rows? 5 rows, and this one happens to have 5 columns. Let me give it another column. It's asymmetric. So this one would have 5 rows and 6 columns. So I'll have to give it a name. I call it nums because it has numbers in it. So what's the value of nums 1, 0? 4. Yes, sir. 4. So I hear 4, and that was a really stupid question, right? Because is it this one or is it this one? That's the wrong one. Okay, so he says it's this one. So let me actually change this one. It's something different. And the answer is 4 because it's row 1, column 0. So you first have the row index and then you have the column index. So the rows go this way. And the columns go this way. Okay. Row 0, row 1, row 2, row 2. Yeah?
So it would be 5 then?
Row 1.
Yeah, because it would be on the 0, 1. Okay, never mind. Okay. Just kidding, I was a little confused.
Yeah, it's confusing. So, when I get confused, and I do get confused just like everyone else, I draw myself a little picture. I number the rows, I number the columns, I write rows and columns. I really do this because, and here's why I get confused. And I'm not sure this is going to be helpful, but I'll do it anyway. So when I look at my real x-y axis, and in computer science the y-axis always points down, you notice this, right? That the x, the 0, 0 is in the top left corner of the screen, and then the y-axis goes downwards. That's because the first computer graphics people came from Australia. So, yeah, no?
You got it.
Thank you. So let's say I have a rectangle here where that starts at the point here. This would be x is, say, 20 and y is 10, right? And so in this coordinate system, you have x and y, and you first go to the right, and then you go downwards, x and y. And with two-dimensional arrays, it just happens to be exactly the opposite, that you first go to the rows downwards, and then you go to the right.
I just had it confused with x, and I'll go
Yes.
right, then,
And every time that I alternate between 2D arrays and doing graphics, I confuse myself. I read it. And so at that point, I draw a little picture, I number the things, I write the rows and the columns, and then unconfuse myself again. But it's not surprising. It's just unfortunate that we have these two different conventions. And I just have to draw the picture every time to remind myself. And so I try to remember, oh, X is the columns and Y is the rows, and I can't remember that either. I draw the picture. Alright, I fill this thing here with my favorite number. That's not an algorithm, it's an array, so it's a simple assignment. Something equals 42. So I can give you the right-hand side for the I need two brackets, one for the rows and one for the columns. So he does 4, 4. And I guess it is. I meant to put it behind here. To make it asymmetric. I meant. Oh no. 5. What the? We're always stupid. No one asked for you. Okay. Do it again. 0 to 4, 0 to 5, back here. And so the whole thing was called nums. So, nums. Wait, what is it? 4, 5 or 5, 4? Rows first? Columns. 4, 5. It's 4, 5. So you do have to remember that it's the row index and then the column index. You just have to remember that. Row index comes before column index. And so that's what it is. It's nums. Alright. Set all of those here around this diagonal to some fixed number, say to 42. Which ones are the ones on the diagonal?
Whenever I equals itself.
Okay, so how do I write it?
I.
Yeah. This fills everything in the diagonal. How do I fill everything along here?
very careful.
I0. He says I0. Let's see if that makes sense. So the rows go from 0, 1, and so on, and the column is always 0. Well, the column is always 0. That makes perfect sense, right? Yes, and I goes from 0 to whatever. Now, to what? So it goes, in this case, from 0 to 4. And in general, let's say we knew that this array here had dimensions, some variable dimensions, R rows and C columns. Then here, where would I go to? R. Yes, I would go to 1 less than R. So, why do you care about these kinds of things? Because it's very common when one operates on these, say to model some kind of terrain, say in a game, for example, or when one has a maze. It's just very common to have to be able to build a wall around the entire perimeter, and then you might have to put like ones around the entire perimeter, and then you have to know how to get to these points. The other thing that's really important, and that sadly is not so good in the book. When you do these kinds of games or simulations, a very common operation is that you have some kind of a cell here. So this thing here has coordinates ij, say, and then you need to find out what are all the neighbors. And so there's various games where you have some kind of character sitting here, and if that character is overcrowded, then it dies. And so I would need to find out what are the neighbors. So what is the coordinate of this one here? So here I wrote just with, I guess I should write in brackets like this, right? So this is ij. What is this one here? So I hear an ij plus 1. Okay, and that's correct, right? Because over here I have the rows, so this must be row number I. Over here I have the columns, so it must be column j, that's how it got to be ij, and then you can read off that the next column is j plus 1. So, how about this one? I minus 1? J. Exactly. So, and you can read it right out if you make this little picture, right? So it's very important that you make those pictures when you need to do this kind of computation. In the next homework, you're going to be having something where you have to do exactly that. I'm going to make you count all the neighbors of something. And then you're going to have to look at these 8 different positions and see if they're occupied or not. That's a little bit painful about 2D arrays, but that happens all the time. Is here I have my array. Basically means you're here and now you look at all of these locations, and there's 8 of them, 1 in each of the 8 compass directions, and then you see what's in there, except there's not always 8. Like where don't you have 8? Like here, how many do you have? Here, this fellow only has 3 neighbors. This one here has how many neighbors? This one has 5 neighbors. And that means that when you check for neighbors, you always have to check if I is greater than 0. Double check whether you can step backwards. And then it's okay to look at I minus 1. not yet at this end here, at the bottom. How can you tell why that's at the bottom? Yeah, so he says something about the last row. How many rows do I have? Why is no one asking me? How many rows do you have? You can't answer the question without knowing how many rows you have. So let's say I have R rows.
Some arbitrary.
Some arbitrary number, right? Where? So I have all rows, let's say. So I'm going to that are not yet at the bottom. So that's okay to look at one further down. So he says if I is less than or minus 2. Is that what I heard you say? Okay. Why is it minus 2?
Well, are you saying like the middle dot has to be...
So I'm saying that over here my test should fail, because and then I would crash with an array index out of bounds exception. But over here, it should be still okay. And so you propose to say if I is less than or minus 2. And that's kind of an intuitive sense, right? Because I have r minus 2, and if I put r minus 2, then I'm surely far enough away from the edge. But can you do better? Do I need r minus 1? The gentleman over here is offering r minus 1. Do I need r? Okay. Well, it's yours at r minus 1. And in fact, if I is less than r minus 1 is the correct answer, because then when you look at I plus 1, then I plus 1 is less than r, and the valid indexes go from 0 up to r, but not including r. Alright, so these are kind of the things that you need to know to navigate around the two-dimensional array. Otherwise, two-dimensional arrays are pretty straightforward. They just have 2 indexes instead of 1. The final thing is, what if you want to visit all of the cells? And for that, you need to have a double loop. I'm just going to say visit, in my case was nums. And when I say visit, it depends on what you want to do. Do you want to fill the entire array with this particular number? Then you would say nums ij equals. Do you want to print it out? Then you say print nums ij. You don't want to do different things every time. But the general algorithm, the general thing that you want to remember is to visit absolutely everything. You need these 2 nested loops. So what it does, when you have your array, it visits I is 0, j goes from 0 to c. It visits them just like I'm filling them in now. Then I becomes 1, it visits the next row. I is 2, it visits the next row. And so on. And that way it fills in the entire thing. So those are the basic strategies that you need to maneuver around things. Alright. See what we have in terms of the law. I'm always going to do this in a group of 2. So here you have to make a pair. Let me make this a little bit bigger if I can. So over here I have a two-dimensional color values, where these colors, could be white, red, blue, whatever. What does this code do?
Every square flows. It fills up.
What?
It fills up every square to be white.
Exactly. So we had one look at this and said, oh, this is the loop that we just saw. That's something to every element. And what does it do to every element? It sets it to white. So this loop here fills everything with white. So what does the loop over here do? Let's look at it closely. First of all, notice this thing here. The first 2 lines are the same as the first 2 lines here. So this is another one where we visit every single element. So the element array is called colors. You see over here we said it, colors ij equals. And over here we're reading colors ij. So we're setting the current color to that color, which could be any color that we'll put in there. Originally it was white, but presumably your code here is going to make tasteful hues of pinks and purples. And so all those colors are going to come off here, one at a time. And we're going to set them to say that's the current color. And then we're going to call g2.fill. And remember that fill uses the color that was just set. So what are we filling? What are we filling? This is not rocket science. What are we filling?
A rectangle.
A rectangle. Very good. It says so, right? We're filling a rectangle. And where's this rectangle situated? So the location of the rectangle depends on I and j. And the size of it is fixed. So that's some grid size, which I believe is 20. Let's say it's 20. So it makes a 19 by 19 rectangle, also known as a square. And the location of that rectangle is just depending on where I and j are. So, and the reason that the j and I are flipped here is because of what I just talked about, that the x and y and the rows and colors come to the opposite side. So this simply draws all the rectangles with the colors that you stick in the array. Alright, now switch here. So we're supposed to fill different patterns. So first of all, I ask you to make this pattern here and group of two. then of course color that. Now, this is all the time. And then come up with some different patterns that you want your opponents to fill it. But of course,
I'm down to do that.
so here's how the game works, is that you play against you two. You come up with a pattern that you want them to do. They come up with a pattern that they want you to do. But you can't say, I challenge you to do it yourself. So they won't stop you from making, crazy patterns. But of course, if they don't challenge, then you might have to do their pattern. So,
Could you,
if you have a pattern that goes like the smile, then I would say, it's probably a little hard. But if you have a pattern that goes, like this, or maybe even like the British flag, like this, that might be doable. Come up with something, maybe a box, 2 boxes. I don't know. Come up with something that you think is doable.
I don't want to do the car.
Yeah, car, of course. No, of course. It's too much.
Tires, engine, bunch of...
So what comes out with a car is you could have a rectangle that's filled like this, and then you can just have one thing here. You can probably do that, right? For the tire. So you could probably do something car-like.
I have to finish the cars lab.